Welcome. Machine learning continues to power new applications and business models, helping companies detect fraud, personalize user experiences, improve customer retention, and much more. As these companies grow from a handful of production models to a few dozen or a few hundred, they're seeing a huge opportunity to look at the ML development process completely differently. Think about all the effort that goes into making great ML features. What if you could capture that and reuse it? What if data scientists could share features across teams and models? In the next 40 minutes, you'll learn how a feature store helps you build new features more quickly and share them with other teams. You'll be able to build better models and improve your time to market by not building from scratch. My name is Mark Roy, and I'm an ML architect at AWS. I've been designing software for decades, and now I spend most of my time helping companies architect ML solutions at scale. So let's take a look at our agenda. So I'll start by introducing SageMaker Feature Store and how it helps you get a better return on your feature engineering efforts. Then I'll dive deeper into a number of Feature Store topics and show you 3 hands-on demos. First, I'll take you on an end-to-end tour to see how easy it is to build and use features. Second, I'll show you how you can build scheduled feature pipelines with only a few lines of code. And in the last demo, I'll show you that SageMaker Feature Store has the performance and the throughput you need for production ML workloads. Stay tuned, and in the end, I'll give you a set of resources to help you get started as well. So let's start with an overview. So this is just a reminder that data scientists spend more than half their time in the feature engineering process, getting features ready for their models. This is really an expensive proposition, from finding data to cleaning it up to coming up with new features, looking at correlations and so forth. Anything we can do to impact this one part of the process is going to go a long way. So what typically ends up happening, unfortunately, here's an example in an insurance company where there's a number of key data sources that a lot of different models end up using. But when a team starts to build their first model, they build up their own feature pipelines. And unfortunately, the second team comes along to build a model and they're not aware of those other features, or there's really no easy way to share them across teams. So guess what? They end up having to do the same work over again. And that happens endlessly in a given enterprise. So this leads to feature duplication, slow time to market, and then inconsistent or inaccurate predictions. So how does SageMaker Feature Store address these challenges? Well, there's a number of capabilities that it offers. Feature Store gives you a secure way to store, discover, and share features, covering both real-time inference as well as training use cases. So you get both batch and streaming feature ingestion. You've got online and offline features, so you can do real-time predictions as well as historical data for model training and batch scoring. You've got a catalog of features and metadata to do discovery as well as reuse. And it's done in a secure fashion. So you can actually control who has access to what features. You can use encryption. And this is a fully managed service. So you don't have to build up the infrastructure yourself. And it comes with high performance, as you'll see later on. And it keeps consistent features between both online and offline stores. So if we come back to our example, in the new world, you've got a feature store that you can feed repeatable feature pipelines can feed those feature values, and then you can reuse them across teams, across models. And so when this third team comes along, they're able to, let's say, find 70% of the features they need and maybe only have to invent a handful of new features to come up with a great new model. So you've got discovery via search or browsing. You can reproduce feature transformations, get accurate training data sets, and get low latency inference, as well as consistency with training data sets. Let's get a little bit more context here. Here's both the online and the offline store within SageMaker. the offline store is kept in sync with whatever updates are made. You can then use SageMaker model endpoints or your own hosting mechanism to get features in real time at low latency, as well as get training data sets extracted for model training or batch data sets for scoring. On the ingestion side, you can do either streaming or batch. In the streaming case, you could use Spark Streaming or Kinesis or managed Kafka to do transformations and ingestion in real time. And then for batch, which is a really common scenario, you can go at whatever data sources you need to and do, let's say, nightly or hourly or weekly batch feature pipelines to keep those features fresh to support both online and offline use cases. Here's the little bit more context about how Feature Store fits into a larger ecosystem. On the left, we've got capabilities to help you do feature authoring. So you could do low-code or no-code feature engineering with SageMaker Data Wrangler or Glue Data Brew. You can do feature processing on Hadoop with Spark, on EMR, or with Glue jobs, or even SageMaker processing, which we'll show you a little bit later on. Streaming, as I mentioned, with Kinesis and Kafka. And on the right, for online inference, you could use your own mechanisms or use SageMaker hosting or Lambda. You can do training using SageMaker training or your own training ecosystem, batch scoring with SageMaker. And you can use tools like Athena to do ad hoc querying and creating reproducible training data set extraction. On the top, we've got discovery mechanisms via APIs to find features and metadata, or you could use it interactively with SageMaker Studio to browse and search. And on the bottom here, we've got, of course, feature pipelines, and you can use whatever mechanisms you see fit in your world. Here we're showing the use of either step functions or SageMaker pipelines or even Apache Airflow to make repeatable, reproducible feature pipelines to ingest data into the feature store. You could even use things like EventBridge for scheduling. Okay, with that, it's now time to go into the first demo, where I'll give you a quick tour from end to end. In this demo, we'll give you a quick end-to-end tour of SageMaker Feature Store. In the next few minutes, you'll see how easy it is to create a brand new feature group, ingest feature data, explore both the online store and the offline store, extract a training data set, train a model, and make predictions with features pulled from the online store. We'll even throw in some row-level time travel at the end to keep things interesting. Let's dive right in. We're using a Python Jupyter notebook in SageMaker Studio, and we start by importing a handful of utility functions to make things as simple as possible. We'll be building a customer's feature group. We'll start by loading in some sample customer data. You can see there's a few columns here, an identifier, a timestamp, a zip code, and a churn label. So here we'll create the actual feature group. We're going to create it based on that pandas data frame. So we can automatically identify the set of feature names and feature types. We just tell it, here we've provided some tags as well to help identify the feature group. And we tell it what the ID name is and what the event time name is. In our case, we're using update time. So the feature group is now available. Let's prove that it's out there. We'll list all the feature groups that have the name customers in it, and there's ours. And now let's use the feature group description. Here we're just pulling out the feature definitions from that description. You can see we've got the feature names and the data types as well. We added some tags earlier, so in this case we've got a tag here saying how we can navigate to the documentation for that feature group, going to my wiki website. Now that the feature group is out there, the schema is defined, let's ingest some data, and SageMaker makes it really easy here because we can take an entire pandas data frame, and simply ingest that with one call. Let's prove that the data made it in there. So we'll get the latest feature values from the online store. We've picked a few IDs, we've picked a few features, and voila, we've got the data returned. You don't have to specify the individual features. Here we're getting those same identifiers and getting all the features available. So that's a quick look at the online store and creating a feature group. Now let's get the full history of feature values using the online store. Using the offline store. The offline store is append only. New records get added, not updated. So let's ingest a couple more sets of data. We'll change the timestamp on our data frame to be February 2nd, and we'll mark all those zip codes as 2s. And then we'll ingest that, and then we'll change the timestamp to February 3rd and the zip codes to all 3s, and we'll ingest that as well. Here, we're actually going to get the historical offline feature values for a couple of IDs, ID 5 and 6, for all features. And I'll pause the recording right here and come back when the data is available in the offline store. The way SageMaker works is when you ingest data, it goes in via the online store. That data is automatically synchronized with the offline store to avoid any skew between your training data sets and your inference data sets. That usually takes a few minutes, so we'll start the recording back when the data is available. Now the data is available in the offline store. You can see we've got multiple copies for each ID. With different timestamps, February 1st, 2nd, and 3rd for ID 5 and 6. Now let's show that the latest feature values can also be retrieved from the offline store. There's some simple SQL to deal with an append-only store like this, so we can get the latest versions. You can also navigate to the data in the offline store, which is held in S3. So here we can just get back the link directly, and you can see that it's partitioned based on the year, month, day, and hour. And you get individual Parquet files collecting sets of records over time based on your ingestion patterns. You can also retrieve the glue table. Here we can navigate directly to AWS Glue, where SageMaker has automatically created a glue table with the right column names and data types. This makes it easy to go to things like Athena and run interactive queries. Here you've got a set of tables. You can make your own SQL here and run that interactively. Okay, here we can get back the total number of records in the offline store for this feature group. Here we can look at the full history for all IDs. So here we're just getting back a data frame with all of the records that we've ingested into this particular feature group. Let's also show that when we did those subsequent data frame ingests, that the online store only ended up with the latest values. So whereas the offline store keeps a full history, the latest feature values from the online store have the most recent timestamp and the most recent feature values. Okay, now let's train a trivial model here with features that we extract from the offline store. So we'll get the latest offline features for the zip code feature as well as the churn label. And we'll do a quick train test split, train this trivial model and make some predictions. And then here we'll show how you can feed predictions with features from the online store. So for customer ID 4, let's look up the latest feature values from the online store. Pull out the zip code, which is our main feature that we're predicting on, make a prediction with that, and print out the results. So we've predicted a churn for customer 4. So I promised you some time travel, so here let's take a quick look at that. So with the offline store being an append-only store, keeping track of the full history, we can do things like, what did the features look like at the beginning of February 2nd? And voila, you can see that they all had zip codes with 2s. And we could say, well, what did it look like at the beginning of February 1st? And yes, all of the records had zip codes equal to 1. So that's pretty straightforward, but now let's look at row-level time travel. So to make accurate training data sets, this is really pretty important. So let's say we've got a set of training events that we're looking for across various customer IDs. Here we're looking for an event that happened at 8:30 in the morning on February 1st for customer 6, another one on customer 5 on February 2nd at 10 in the morning, for customer 1 on February 3rd at 1 in the afternoon, and then another one for customer 6 again, but on February 3rd at 7 in the morning. So we take that set of events, and what we need to do is row-level time travel to get the features that were in place, the exact feature values in place for this customer at this time. Now, of course, we didn't ingest data at every single timestamp, so row-level time travel takes that into account and gets the most recent feature values without looking into the future and having any feature leakage. So here we do a call to do row-level time travel. We'll get features using this event data frame, telling it what was our event time column, what feature group we're looking at. And you can see that, yes, we did get back 2 different records for customer 6. And when we were looking for the February 3rd values, we got the values that were at the beginning of February 3rd. And when we looked for an event from February 1st, we actually got back the values at the beginning of February 1st. So very powerful capability here to do row-level time travel to make accurate training data sets. Don't forget to clean up your feature groups. In our case, we're going to use that in the next video. Okay, welcome back. Now let's take a closer look at how feature ingestion works. There's a couple of core APIs to understand. First is put record. The put record API, you just specify what feature group you want to be ingesting into, and you pass it a record, basically a set of name value pairs identifying the record itself. On top of that, you can use the Python SDK, which, as you saw in the previous demo, makes it easy to just take an entire pandas data frame and ingest it directly into the feature store. So you identify your feature group, you get a feature group object, and you can just, with one line of code, ingest the entire thing. Let's take a closer look at how the put record behavior works and what it means in both the online and the offline store. For the online store, you get access to the latest feature values for each record. In the offline store, you get the full history. So let's look at an example. So here we're doing a put record call on 3 different identifiers, 1, 2, and 3, at 3 consecutive timestamps with 3 different values. Now let's say we have some new events that drive us to put in a new feature value for identifier 1. So at time t4, we say the value is now 0.4, and at time t5, it's now 0.5. So where does that leave us in the feature store in the online case and in the offline case? Here's the online store after that set of calls. So we've got one record for each identifier, and you'll see identifier 1 has the most recent value only. So it's got the timestamp T5, feature value 0.5. As we look at the offline store, you see every record is covered, ID 1, 2, and 3, and you'll notice that ID 1 has 3 separate feature records. So you've got the full history from the original at time T1, and now T4 and T5 are all there as well. So this gives you the ability to do time travel, to do point-in-time views of your data. You can look back across a history of, let's say, transactions or events to extract training data sets, or even extract appropriate batch scoring data sets as well. Let's take a look at what are the overall requirements that customers come to us with when they're looking at feature ingestion at scale. Typically what they're looking for, number one, is make it easy to support multiple input files. Often there's just a collection of a large amount of data they need to ingest, and they need to ingest it as fast as possible. And then lastly, they want to be able to integrate with a wide variety of different scenarios. So you may want to iterate in a Jupyter notebook, doing a bunch of ingestion ad hoc, or maybe you've got an existing feature pipeline that produces data, produces featureized data, and you want to take the results and ingest them at scale very quickly into the feature store. Or a third scenario might be you want to interactively, with a low-code, no-code type of tool, create your feature transformations, and then save that off as a pipeline that does both transformation of new data as well as ingestion of those features into the feature store. SageMaker gives you all of these. And let's show a little bit more detail about how SageMaker scales. So when you're doing feature ingestion and you've got hundreds of gigabytes you need to ingest quickly, let's say we've got all of those dozens of files in S3 organized into various partitions, and you've got a feature group that you want to populate. What SageMaker lets you do easily, and we'll see that in a demo, is spin up a processing job. Here we're doing a processing job using the Python SDK, where I just say, hey, I need n instances. I don't have to worry about provisioning this. I just configure it and say I need n instances. SageMaker automatically shards all of the input files across the number of instances that you've specified. And on each instance, you can say how many processes and workers you want. And on what that leads to is massive parallelism of client calls to that put record API. So under the hood, each instance is calling the ingest DataFrame method, but it's doing it in a massively parallel fashion. This gives you really high throughput and lets your ingestion jobs finish quickly. You can also choose to use PySpark as well. So the same scenario with multiple input files. Here we've got a primary node and a number of worker nodes. Again, you don't have to pre-provision anything. You just specify the configuration and then launch the ingestion job or transformation job as well. And SageMaker, using Spark in this case, will automatically take full advantage of all the available resources to drive massive parallelism. And SageMaker is able to keep up with whatever throughput you need to get your features ingested quickly. We also have a library for Spark. So if your teams are really comfortable using Spark environments, making Spark feature pipelines, they can take their Spark data frames and with one line of code, ingest them into a feature group. We even have support for direct ingestion into an offline store, which is great for various backfill scenarios. Lastly, before the next demo, here's a picture of an overall MLOps scenario where we've got an end-to-end pipeline for model development with a feature store right here in the process. You might have n different feature pipelines feeding various feature groups. Other teams may be also loading their features into the same feature store. You could have a step here that's doing data set extraction across a number of different feature groups, and then feeding training, model evaluation, and even registration into the model registry. You could picture model deployment being involved here as well, all fed by a wide variety of different data sources, and all wired up to managed code repositories and data repositories so that you can reproduce all of this, and you can easily find out and troubleshoot what happened if you're trying to understand different predictions, for example. This can all be done on demand or scheduled, or even triggered by check-in of new code for feature transformation, or triggered by the arrival of new data into your environment. Okay, so let's move on to demo number 2, where we'll take a quick look at how to easily schedule feature pipelines. In this demo, we'll show you a way to create a scheduled feature pipeline to transform raw data to feature data and ingest those features into SageMaker Feature Store. When you have production-ready features to use in real models and to share with other teams, a feature pipeline gives you a repeatable way to keep your features fresh based on the latest source data. There's a number of ways to do this, and in this demo, we use a Python helper function that lets me write a single transformation function and schedule it as a feature pipeline with one call. Under the hood, this example uses Amazon EventBridge for scheduling, SageMaker pipelines for execution of a SageMaker processing job. Let's see how it works. I'll show you 2 examples. The first pipeline uses an empty transformation function. In this case, we've got some existing ability to generate the feature data, and we're simply wanting to run a daily job that ingests the very latest feature values. Okay, here's the first function. It's an empty transformation, so it's just taking in the data frame and returning it. So let's just try it out locally to make sure it works. We'll read in the original customer CSV, run that empty transform. We can see that it doesn't break. So then we're going to next make sure we push the raw source data to S3. That's where it's going to, the pipeline will pull its data in this example. In practice, you would have a some mechanism to push the input data on a regular basis, so that this pipeline would pull fresh data, do transformations, do ingestion into the feature store. So now that the data is there and we've written the function, this is a one-line call to schedule that function as a feature pipeline. We're going to do it with a schedule of daily. And as part of creating that pipeline, it will launch automatically the first version, first execution of that pipeline. So let's check to see when it gets started, and voila, it is executing. We can use SageMaker Studio's ability to look at pipelines. We'll refresh here. See, we've got 18 seconds ago a brand new pipeline was created. We can drill into that, and we can see that the very first execution of that pipeline is happening. You can see that it's got a pretty exciting feature pipeline here of 1 step, and so forth. So that'll take a little bit of time to launch the job and execute it. So let's pause here and come back when that's complete. So the job completed and the data was added. We ingested a new copy of the original source data. You can see the write time came a little bit later here, but the same event time. The job succeeded. So what you saw in this example was writing a simple empty function here. and then with one line of code, scheduling a repeatable feature pipeline to ingest every night into this feature group. So let's show one more example. First, let's prove that the online store still has the latest version, even though in this example we ingested another copy of the original data. The online store has the most recent value based on the event timestamp. Let's show another example here. We'll disable that first pipeline so we don't run it tonight. Here we're going to come up with a couple of new features. So let's add a persona feature for the customer and some random new feature that's going to be a floating point. So we can see the original features plus persona and new feature 1. Here we'll create a new feature group, customers v2, from that data frame. So it'll have all of those feature definitions. And let's make sure when it's complete, we'll do a quick describe on the feature group to show those feature definitions. And make sure the additional features are there. And once that comes back, there they are. Now we're going to define our apply transforms is going to take in a data frame from the data source, return a data frame, but in this case we're going to fill in the persona column based on a little function we've written here, choose persona, and this is just a simple example here. We're just going to say, hey, if for row ID is greater than 3, use persona 0, otherwise use persona 1. And for new feature 1, we're going to make it use the persona value and then use some random number and then multiply the zip code by 2. Obviously a toy example here, but you can fill in apply transforms with whatever logic you need to populate all of your features. You can use whatever imports you want, write an arbitrary Python script here that will be included in your feature pipeline. So let's save that. Let's make sure it works locally here before we bother scheduling a pipeline. So yeah, it looks like it does. So it's going to be creating personas 1 and 0 here based on the row ID. It's going to create this new feature which is going to double the zip code and then add some random number to that. So let's schedule this. This should be v2. Let's schedule this new pipeline to run hourly in this case. We're going to use the same raw data that's been already uploaded to S3. We're using the new feature group name. Once that completes, we're going to check to make sure that this new feature group is fully loaded with those new features. So we will pause for that to happen and show you the results when it is complete. Okay, going back to the pipeline panel, we can refresh that. We can see that it created a customer's v2 pipeline, and it is executing as well. So we will wait for that to complete and see the results. Okay, you can see that the pipeline completed. We were iterating, waiting for the online store to have ID number 2 in our new feature group, and it does. You can see when we look up that record, we get the new features, persona 1 and new feature 1 are completed. So we've got 2 examples here of scheduled feature pipelines with trivial coding and putting in place a repeatable process to keep your feature values fresh for a feature group. Hey, welcome back. Now that we've talked a lot about getting features into the feature store, let's see how we can use features that are already ingested. So here we've got an environment with a number of different feature groups established: customers, orders, claims, visits, and so forth. And SageMaker sets up a glue data catalog automatically for you. And then you can use tools like Athena to do ad hoc querying using SQL. Here we're saying, hey, select various features and a label from a particular feature group. You could do joins across feature groups, extract those into training data sets, and then perform training using your own environment or using SageMaker training. You can do the same for batch scoring as well. Here we're selecting the ID, various features, extracting that, and then running a batch transformation. Let's talk about how to work with the online store as well. There's a couple of APIs of interest here. One is getRecord, which lets you pick a particular feature group and a specific identifier, and either all of the features associated with that record, or you could pick a subset if you'd like as well. There's also an ability to get a set of records at once. That's via batch getRecord. You can specify multiple different feature groups, and within each of those, multiple different record identifiers. Let's look at a specific example of batch getRecord, just so you understand it a little better. Here we're saying, from the customer feature group, give me back the features for customer 1 and customer 3. And for the product feature group, I want product number 8, but only feature number 4. So these yellow values would all be returned with low latency with a single call. So that's a pretty powerful way to feed your online predictions. Here we're talking through a specific use case. So let's imagine an insurance company where we've got customers using our mobile app. Internally, we've got insurance adjusters using another app. And as customers upload images about a brand new claim, they just got into an accident, they've snapped a few pictures of the fender damage and the hood damage. And we monitor those events, and we're able to, in streaming fashion, run a damage classification model and feed those results into the online feature store. Separately, we can also have batch ingestion, either hourly or nightly or weekly, doing some transformation to develop features based on claims or customers or some text interactions. So the online feature store has all of these available. And then we can have models running in real time here to calculate vehicle loss or to do various natural language processing as well. And then the adjusters and the customers would get real-time feedback with really low latency online inference, taking advantage of the feature store to pull those feature vectors in real time. Okay, it's time for our third and final demo where we'll take you through performance. So in my role, I'm fortunate to get to talk with data scientists and ML engineers at companies like yours every day, and they're building real world models, and performance is always a top tier requirement. So it's one thing to play around with some models on your laptop. It's a different story when we're talking about business critical production applications. And in those cases, low latency and high throughput are must-haves. So in this demo, let's take a quick look at SageMaker Feature Store performance. In this performance demo, we'll show feature lookups for near real-time inference, and then we'll show feature ingestion. So what do I mean by near real-time inference workloads? Let's say you're adding ranking or some other personalization to your website, and you can't have your feature store slow down the user experience. Or maybe you're adding dynamic pricing to your mobile app, and you know your customers will go elsewhere if you can't price quickly. If your team is on the hook for high-performance ML predictions, you'll of course need to look at the performance of your entire solution architecture,
Most of you probably already have scalable web architectures and mobile app backends that meet strict latency budgets, even with sustained high traffic. AWS has been helping solve these challenges for a long time now. What's different now is that companies are applying ML in brand new ways, and they need near real-time performance there also. In many cases, you're handed a requirement to make predictions within 100 milliseconds or 50 milliseconds or even less. And within that overall inference latency budget, you need to retrieve the latest features and get back a prediction from your model using those features. Feature Store plays a key role in that, getting the latest feature values as fast as possible, just in time for a prediction. Okay, so with that context, let me show you a quick demo using our old friend, the customer feature group. We'll kick off this test and take a quick look at the code here. So here, to keep things simple, we're just doing a loop 8,000 times through a call to get record. And for each call, we track the latency, and then we print out the performance. In this simple example, we had an average of 6 milliseconds. P90 was 7 milliseconds, and P95 was 8 milliseconds. So not too bad. Your actual performance depends on a number of factors, including the payload size. This example showed the use of getRecord API. SageMaker also gives you the batch getRecord API to grab many records in a single call, even across different feature groups. And when your model inference depends on large numbers of records, this will save you precious milliseconds. So SageMaker is built to scale and can handle feature lookups at really large TPS numbers. Now let's look at feature ingestion. Think about your ingestion requirements. Do you need nightly batch pipelines feeding features on 50 million customers? Or maybe streaming feature ingestion on millions of events per hour? You can make these workloads happen in a bunch of different ways, and SageMaker Feature Store gives you the ingestion throughput and latency that you need. Let's look at an example. Say you want to load new feature values every hour for 2 million customers. And to make the example a bit more interesting, I've created a new feature group with more than 200 customer features. So here's a sample data file, and we're showing the original features plus a couple hundred new features with some random numbers in there, just to demonstrate the point. To keep the focus on feature ingestion, let's assume you've got an existing hourly pipeline generating all of these to the tune of about 2 gig of feature data and saving it to S3. So we've got all these input files around in S3 ready to go. So let's take a look. If time wasn't a factor, you could just read each file and call put record for each record. Since we have a limited time window on our batch cycle, we need to do much better than that. So we need to get these latest feature values into our online store and added to our offline store for future training, and it needs to happen within a 5-minute batch cycle. So we do a quick in-notebook experiment here to just see how long that would take to ingest in the notebook, and that takes about a minute. So if we do some simple math here, that approach would get us about 20 minutes for the 2 million records. Clearly not going to cut it. So also, it's not something you're going to want to do for a production workload, is to do the ingestion in a notebook. So you need something repeatable and scalable. So instead, you can spin up a feature pipeline. So SageMaker gives you a number of levers to drive down ingestion times. You define a cluster configuration by simply picking the instance types, the number of and the number of instances. You also get to set the max processes and workers to use on each instance. SageMaker shards the input files across the cluster, and each instance will push Feature Store as hard as it can. Under the hood, in my example, I'm using the Python SDK to ingest a pandas DataFrame, but I could have just as easily used Spark instead. So let's see some results here. So I've got a little function run once that takes in the desired instance type, how many instances you want to use, where the input data is coming from, what feature group to use. And in this case, again, we're just doing direct ingestion, not any transformation. So I've got it set up to try out different instance types, and it will just update feature pipeline and run it. So we've got a particular input URI for S3. That's where we've got those 20 input files with a total of 2 million features and 2 million feature records with 200 features. So I've run 6 examples. The first 4 times I've run with a M5 4XL, which has 16 vCPUs. And I'm going to run it with one of those and then try scaling up from there. And then after that, I'll run with C5 9XLs, which gives you double the number of vCPUs, and let's see what happens. So here's a view that we've got from CloudWatch showing the runtime of the ingestion, as well as the consumed write request units per minute. So that gives you a measure of the throughput of the ingestion. So let's take a look at how we did. So it looks like this first job took about 20 minutes, which is what we expected. So that was with the same instance type, but just one instance running on those 2 million records. But look what happens when we scale up and we try 2 instances, and then 4, and then 8. So we go, by the time we get to 4 instances, the job takes 4 times shorter. It's only 5 minutes. We've got throughput of nearly 1 million write request units per minute. And then we go even further. We can cut the job time down to 3.5 minutes using a set of 8 instances and getting up to 1.6 million throughput. And these last 2 examples are using switching over to a C5 9XL cluster. Here we're just using 2, and here we're using 3. So I can achieve the same 3.5 minute job time with only 3 C5 9 extra larges instead of 8 M5 4 extra larges. So in our simple example, we were able to ingest at a pace of 100 gigabytes an hour. That might be just fine for a lot of your workloads. And if not, if your company is in hyper growth mode and you jump to, let's say, from 2 million customer records up to 200 million, SageMaker will let you scale up and out as needed. And as you can see, it's just a simple configuration change.
Okay, welcome back. So you saw a few examples there of how we can both scale up and scale out with feature pipelines, as well as get low latency access to feature vectors for inference. So before we close the webinar, let me touch on a few other capabilities. First of all, feature monitoring. Here's a quick reference architecture where you can take your offline store features, have processing jobs that analyze those features, and then you can have scheduled monitoring jobs that will give you back feature statistics, look for violations where you're going outside of certain thresholds, and can feed data that you would then analyze in a dashboard or in a notebook, and even drive things like model retraining and so forth. We also can integrate easily with Glue Data Brew to give you a user interface that would show you feature group profiles, feature statistics, and then run scheduled jobs where you're getting feature profile data over time, where you could visualize feature drift detection. So this is really important for large-scale enterprise-level feature deployments. We also support ML Lineage. So here we've got a scenario with multiple different feature groups fed from various feature pipelines and a number of different data sources. And these feature groups are used by a number of different models. And we've got some models that use multiple feature groups and some feature groups used by multiple different models. So we want to be able to answer questions both from right to left and from left to right in this picture. So for a given fraud model, let's say, you can identify, well, which features are used by that model. And then for those features, what pipelines do they come from? Let's look at the source code that drove that. What data sources did that fed those feature pipelines? And then vice versa. If you're looking at the telematics feature group, well, which models are using that in case I need to upgrade that feature group over time? Who should I be talking to? Okay, let's jump into a few resources before we wrap up. I want to help you get started quickly. Here's a brand new workshop that we've made available for you. Here's a public repository that you can go download and run in your own account. We can help you with that as well. And we'll take you through 6 different modules from establishing new feature groups to doing training and inference, low latency feature vector lookups, batch get record, and multiple different flavors of ingesting features using feature pipelines. Here we've got 7 different blog posts with corresponding code repos as well, anywhere from topics on streaming ingestion to feature reuse across accounts, point-in-time queries, and more. And then lastly, we've got links to all kinds of documentation, developer guides, as well as API reference material as well. So as I wrap up here, I just want to highlight that we're seeing some great momentum from both enterprise and startup customers as they evaluate and adopt SageMaker Feature Store. One of our flagship customers is a large mutual fund firm that went live in production a couple of months back, with plans to scale to many hundreds of feature groups by the end of 2021. Another financial customer went live earlier in the year. One of their key requirements was consistency across real-time and batch applications, as well as the ability to work across multiple accounts. And we're seeing adoption in other segments as well, like online real estate, health technology, and e-commerce. The common themes are data science, productivity, faster time to market, and fast online inference. Let me leave you with one key takeaway. You don't need to build and manage your own feature store. Instead, SageMaker gives you an enterprise-grade managed feature store built for high availability and scalability. You get an out-of-the-box service to build better features and get a better return on your feature engineering investment by reusing features instead of starting from scratch every time. So thanks for tuning in. I'm really looking forward to hearing from you about your feature store use cases. Let us know what else we can do to help.